A study that came out in February of this year made headlines when it said that the mysterious dark energy that cosmologists think is speeding up the expansion of the universe could have come from the supermassive black holes at the center of galaxies. Two of the most mind-boggling ideas in physics are black holes and dark energy. If there's a link between the two, it would mean that the source of dark energy has been right in front of scientists' eyes for decades. On the other hand, a number of well-known theorists have shown a lot of doubt about the theory. Robert Wald, a theoretical physicist at the University of Chicago who specializes in Albert Einstein's general theory of relativity, which is the standard way of understanding gravity, says, "What they're proposing makes no sense to me." Some theorists were more open to the radical claim, which is encouraging even if it turns out to be wrong. A physicist at the Perimeter Institute for Theoretical Physics named Nayesh Ashforty said this about the discovery, "I'm excited about it. At first glance, black holes and dark energy might not seem to have anything in common with each other. General relativity says that a black hole is an area of space-time that's completely ruled by a gravitational field that's so strong that it keeps the black hole itself alive. Strange monsters are thought to come from the collapse of huge stars to a point so small that only their gravitational fields remain. People think that at the center of galaxies, there might be supermassive black holes that are hundreds of millions or even billions of times the mass of our Sun. On the other hand, dark energy is a mysterious thing that literally and figuratively makes space bigger and is responsible for speeding up the expansion of the universe. Theorists think that dark energy could either be a basic property of empty space or a new type of field that exists in space and is similar to an electric field. So what could possibly be the link between the two? Quantum mechanics says that even empty space must have some kind of energy. This energy is called Hoover energy. Since this is thought to be everywhere in the universe and to have a force that goes against gravity, it's one of the most likely candidates for what dark energy is. In 1966, a Soviet physicist named Ernst Gleaner showed that Einstein's equations could also make things that look and act just like black holes, but are actually just big balls of Hoover energy. Gleaner's work was important because it showed that these things could be made by Einstein's equations. If there were things like this in the universe, it would mean that dark energy isn't spread out evenly across all of space, but instead is only in certain places, like the insides of black holes. Even if it got caught up in these knots, dark energy's effect on making space bigger would still be felt all over the universe. Duncan Farah, an astrophysicist at the University of Hawaii at Manoa, says that if supermassive black holes are the source of dark energy, then these holes would be linked to the constant stretching of space, and their masses would likely change as a result of the expansion of the universe. He also says if the size of the universe doubles, so does the size of the black hole. Farah and his colleagues looked at elliptical galaxies, which have huge black holes in the middle that are millions or billions of times heavier than the Sun. They did this to test this theory. They focused on galaxies that didn't have much gas or dust floating around in the space between their stars. They did this because they knew this would give the black hole in the center of the galaxy a source of food. It's not likely that these kinds of black holes will change much over the course of the universe's history. But the team saw that black holes in the early universe were much smaller compared to their host galaxies than black holes in the modern universe. This means their mass had grown by a factor of 7 to 10. Farah and his team wrote about this in the Astrophysical Journal this month. The team found this out by looking at how ellipticals have changed over about 9 billion years. Farah says that the most important thing to remember is that even though galaxies don't grow, black holes did. If the black holes grew by eating gas and dust from their surroundings, then the same gas and dust should have created a lot of young stars in the parts of the galaxy far from the black holes. This week, Farah's team also wrote in the Astrophysical Journal letters that if black holes were made of dark energy, they would react to changes in the size of the universe in the same way the researchers saw in the centers of elliptical galaxies. This week, that finding was made public. The argument doesn't convince Wald. He wonders how a sphere made of nothing but dark energy could stay still. In addition to this, he claims that the numbers just don't seem to add up. It's known that dark energy accounts for 70% of the mass energy of the universe, whereas black holes account for a mere fraction of the ordinary matter that makes up less than 5% of the universe. He says this doesn't seem to make sense. According to him, I don't see how it's possible in any way, shape, or form that objects may possibly be relevant to observed dark energy. Others are opting to take a passive stance for the time being. Right now, this is an interesting idea, says cosmologist Geraint Lewis of University of Sydney, but there would need to be a lot more evidence on the table if this is even a little bit credible as a source of dark energy. F. Shorty agrees. He says that if there's a link like this between black holes and dark energy, it would probably have other effects that can be seen in the universe, but he can't guess what they are right now. He goes on to say that figuring out exactly how galaxies change over time is hard, and that the team may not have looked into all the possible ways that black holes can grow. Even so, F. Shorty supports the idea of rethinking some of the most basic ideas of the universe. He thinks that skepticism is the best way to fight against new speculative ideas. You say, but if we throw out all the creative ideas, there won't be anything left. The distance between Earth and the black hole is around 27,000 light-years. The Milky Way galaxy has many spiral arms, and our solar system is in one of them. This means that we're very far away from the center of the galaxy. If we could see this in the night sky, it would look about the same size as a donut sitting on top of the moon. Trying to get a picture of a black hole is like trying to get a picture of something that can't be done. Even though it's closer to Earth than the black hole at the center of the Milky Way, it was much harder to picture. The gas around SGR-A and M87 moves at the same speed, which is almost as fast as the speed of light. An EHT scientist named Chiquan Chen from Steward Observatory and Department of Astronomy and the Data Science Institute of the University of Arizona said in a statement, "Thank you so much for watching this video. Stay tuned for more."